All right, so we have, we're going to do a quick exercise on this video of creating basically kind of like a record inside of a database. Let's say that we're a school. We want to keep track of our legal guardians of students. We have a students table, a guardians table, and addresses table. So I'm going to make these all plural. And I think we should be all set here. Perfect. So the way that this is set up is that a guardian belongs to an address. A guardian has a name, a phone number, and an email address. The address has a line 1, city, and state. I know there's more things, but for the sake of time, let's just keep it like that. And a student has a name, a grade, a date of birth, and a guardian ID. These are all associated. So a student belongs to a guardian, and a guardian has many students. A guardian belongs to an address, and technically speaking, an address could have many guardians. Now, when I say I don't need to associate a student record directly with an address, because since a student is correlated with a guardian and a guardian is correlated with an address, I can just kind of follow the lines all the way around. So I can connect from the student to the guardian, and the guardian's directly going to the address here, so we should be all set. Let's create, now that we have a data model, which is just like the representation of the plan that we're going to try to create, let's create some SQL statements like this so that we can create the table, insert a few records of people inside of there, and then query the database a little bit as well. So I'm going to grab all of this, jump over to here, and let's jump out, exit. To make a directory called SQL example, cd into SQL example, open the whole thing in VS Code. All right, so we're going to write some SQL code to create a database and then insert records and then query it as well. So I'm going to do schema creation.sql. You'll notice that when I do .sql, I have the SQL graphic comes up, and I want to create a table with all of these things inside of there. So I'm not really sure how to create, what the SQL is to create, so I'm just going to Google it. So we're going to do Postgres, which is a SQL flavor. Postgres create table example. All right, so there's a bunch of tutorials over here. You could read the official documentation. I find that tutorials point and basically other places that synthesize make it a little bit easier to read. So, okay, let's take a look. It looks like create table, and then the table name, parentheses, all the different columns, and you're going to have to name the primary key one or more columns as well. Okay, that one works. Let's take a look at an example. So we have company. There's an ID on there, which is an integer. It's the primary key, and it's not null, meaning that I can't not have a primary key. Then there's a name, which is text. Okay, that seems to work well for me. Let's just copy this and try to create 3 tables. All right, let's say that create table company. I'm going to create a table called addresses. All right, so address is going to have an ID. Maybe, yeah, well, this one will have an ID. It's going to be an integer, the primary key, and not null. From there, I just kind of continue on. So we have line 1, which is going to be a varchar 255, and you can't not have anything in there, so I'm going to say not null again. Line 2, same thing. So I'm just going to copy the whole line and paste it in. City, state, and zip code. Oh yeah, you're right. You're correct. That's a good point. So Bobby brought up, shouldn't it not be not null? Shouldn't it be allowed to be null because not everyone has a line 2 of their address? So line 1, you have to have something. Line 2, you don't have to have something. City, state, and zip code. All right, so are there any things we should limit? Line 1, 255 is probably fine. Line 2, 255 is probably fine. City, I don't know. There are really long cities.
Like 100 something characters.
All right.
Yeah, that's what I'm saying. Like,
yeah. So what about that's true. Let's say 100 for this one then. Let's take 255, maybe 100. City probably, I don't know, 100 characters. A state, let's just say 2. That one's simple because it's an abbreviation. And the zip code, let's do 5, not the 5 plus 4. That one's pretty simple. We just created a table called addresses, and we're going to move on to the next few as well. Let's continue on. We're going to create a table called guardians. Same thing. They have an ID. They have a name. They have a phone number. They have an email. And let's see, what things can we change? So the name, name is probably okay. 255. Phone number is 10 characters long. Email address is 100 characters. That's probably okay as well. Now we have to figure out how to associate a guardian with an address. And I don't know how to do that, so I'm going to Google it. Postgres, foreign key, example. Let's see. Okay, so there looks like there's something called references. Let's see, let's take a look at what else we have. So this is the official documentation. Maybe there's a W3 resource. Create table. Is there another references or something? This is impossible to understand. There we go. All right, so it looks like there is something that we can reference something else. All right, so let's grab this. I'm going to just throw it inside of here and see if it works. So we're going to call this address ID. It's going to be an integer. And it's going to reference addresses. Lastly, we've got the students. So I'm going to just copy and paste this again. Create a table. The table is called students. It has an ID, a name, a grade. Let's say that it's only 2 characters long because you can go from K through 12. The date of birth. Date of birth. This one we're going to make a date time, which is instead of saving it as a string, we're actually going to save it as a date object. So I'm going to call this date time. And you can't have it be null. And then finally, we're going to associate a student with a guardian. Using the same line of logic on line 15, I'm just going to copy it. Actually, it's already here. So I'm going to call this guardian, guardian ID. It's going to be an integer, and it's going to reference guardians. All right. Before anything happens, I'm going to drop table if exists addresses, guardians, and students.
Sometimes if you have on the guardians table, the ID called guardian ID.
I'm sorry, repeat that one more time.
On the guardians table, you
Yes.
don't have to have guardian ID called guardian ID.
Nope. You can have guardian ID over here, but generally speaking, you just have ID. And
How does the students table know to use that or that as guardian?
Oh, I see what you mean. Like, how does it
Yeah.
know? So the references underneath the hood, if I am not mistaken, actually will associate it for you.
Okay.
But I don't know if that's 100% true. That's why we're going to run it and find out. So I've created a file called schemacreation.sql on lines 1 through 3. If the table exists, I'm just going to drop it because I might make some updates later. And I'm going to create a table called addresses with all of these columns on there. All these data types are in blue, and sometimes they have not null, and sometimes they have nothing. I should probably have not null here. And not null there because a student has to have a grade. Now, what I'm going to do is I'm going to create a database. It's going to be empty. And I'm going to load this file into that database. And let's see if we get anything. So I'm just going to create a database using create DB schools. All right, and if I do pSQL schools, and I do \D to show me all of the tables, right now you can see there's nothing inside of there. It's an empty database. How do I quit? \Q, also Control C? Z? Okay, that one also gets you out. So I'm going to clear the screen. I'm just going to run, I think it's pSQL schools, schema creation.sql. Nope, that's not it.
Just one. I think it's just one.
It's just one? Okay. Oh, I'm going to clear this. So pSQL schools, 1, and then the name of the file. So what this is saying is, inside of the schools database, run this file, schema creation.sql. Hopefully nothing blows up. Oh my God, no. Okay, so it runs through and it says, addresses table does not exist, skipping, and then this one blows up, syntax error at or near address ID. So we were wrong. I was wrong a little bit earlier. Pardon? Oh my goodness, yeah, I forgot that. And that one there. Let's try this again. Clear. And type date time does not exist, so I don't know what that means. Let's just Google that. Date time does not exist. Maybe we need, Postgres doesn't have a date time data type. For a combination of both, you need timestamp without time zone. Let's just click on this.
Yeah.
I think there's a date one. Let's just do date. So I'm going to clear it again, run it one more time, and it works now. So there's a lot of, okay, cannot drop table, cascade, use drop cascade to drop the dependent objects as well. Okay, so let's drop table cascade. So the cascade is important because what's happening here, the error that I was getting a little bit earlier was it says that I cannot drop table addresses because other objects depend on it. When I had previously run this file, I said that a guardian is reliant on address. It belongs to an address. So you can't drop something if something else relies on it. So by adding cascade to the end here, what's happening is it's saying destroy addresses and everything associated with it. So it's also going to like drop the other tables at the same time. So I'm just going to add that on here. So I believe I've created this successfully. I could be wrong, but I'm going to check pSQL schools. If I do \D again, before you saw there was nothing. It said there was no relations. If I scroll up, I can't go that far. But now I have 3 tables inside of here. I've got addresses, guardians, and students. Let's see if I have all of the columns in there as well. I'm going to do \D with just addresses. And you can see that I have line 1, line 2, city, state, and zip code. So I have successfully created a database with these 3 tables inside of there.
Can you quickly just touch on the drop table if it exists? What does that tell?
Sure. So the question was, what is going on with this drop table if it exists? So before, when I was creating my schema, I was basically saying inside of schools, execute this file called schema creation.sql. Because I'm running it over and over again, I've already created an addresses table, but I want to drop it so that I can recreate a brand new one. That's what's happening here. I'm dropping the table if it exists, specifically the addresses table. Same thing with guardians and cascade. So if there's a table called addresses, guardians, or students, I'm going to drop it. But if it doesn't exist, I'm just going to skip it. The cascade at the very end basically says if there's any like requirements where like guardian is associated with addresses, just forcibly drop everything until we have nothing left.
That means to drop it means to put it in the database.
To drop it means to like kick it.
Get rid of it.
Get rid of it. Yeah.
If it exists already, so if it exists already, you're making a new one. So, right? So you
Yes.
drop it.
You drop it and you create a new one.
Yeah.
So I'm saying like if there's an addresses table, drop it. Drop the table completely. Just like completely remove it from the database. So it runs through 1, 2, 3, and then it says, okay, now I'm going to create a table that's the one that I want. All right, so I've got one file that creates the schema. I'm going to have one file that inserts the data into the database. So I'm going to solve this seeds.sql. That's generally how it works. Let's create a few addresses, a few guardians, and a few students. So I don't know how to insert, so I don't know, insert into table Postgres. Example. Let's see, we have a bunch of really difficult things to understand. Oh, tutorials point, the cliff notes of everything. So, okay, so insert into table name, values, value 1, 2, 3. Okay, that seems to work for me. So I'm just gonna grab this and put it in here. So let's create 3 guardians, 3 addresses, and 9 kids. All right, so insert into addresses, values. I'm going to do, wait a second. Insert into table name, values, this. Okay, here we go. This is the one that I need. Insert into addresses. The column names are going to be line 1, 2, city, state, zip code. Line 1, line 2, city, state, zip code. The values that I'm going to pass in are going to be, I don't know, 1, 2, 3, fake street. Nothing, fake town, Illinois, 60603, and I'm just going to kind of continue on with this.
I think you still need an ID.
I don't think I do. I think it'll automatically do, it should automatically generate for me. All right, so let's say we have, I don't know, 125 South Clark Street. We're on the 17th floor in Chicago, Illinois, 60603, and then finally, I don't know, any address? 555 West 42nd Street, unit 1234. Let's say, yeah.
Which one usually generated by default? I forgot how that syntax for
Yeah.
the ID. We can do that.
I don't know. Let's find out.
If you just do insert into values. You have to do it.
I think you have to do it's one statement at a time. Okay. So let's see if this works. If it doesn't work, then we will figure this one out. So before I said inside of the schools database, I'm not doing schema creation now. I'm going to throw in seeds. Please work. Oh, no. No value in ID evaluates not null construct. So it looks like I do need to put in the ID number.
Yeah,
But shouldn't it auto-generate?
we did a generate. Yeah, when we created it, we did generated by. I think I have to go over this
I think if you go back to that original table, you can hit generated by, so
Okay.
we're not null.
Okay, so primary key, Postgres, auto-generated. Okay, how to define an auto increment primary key in Postgres. So instead of you hard coding the ID number in there, which is dangerous because you could have a duplicate record, you want the creation of every single new record to automatically increment, so that you don't need to worry about that. I don't know how to do that though, so we will. That is not useful for me.
You say boobs? What's wrong with this website? Oh, it works. What's wrong too? Oops.
All right. So it looks like we can actually just do serial and primary key rather than int and primary key. So with that, serial, primary key, not null. All right. So because I'm running this over and over again, I want to drop the table because before the ID was just a random integer rather than a serial going up and down. So let's go back. I'm just going to drop the whole database and recreate it again.
What about the other two tables?
Oh yeah, good call.
But nothing was generated, so couldn't you just do the stuff that you just did and bust up on your keyboard?
So I've already created the database with these three tables there before. So now I'm just rerunning this whole script. This whole script is just going to drop all the tables and then recreate them with the proper primary key. I could also update it, but just for the sake of simplicity, I'm going to drop and recreate. All right, so everything works. Drop table, create table, and let's see if I can insert things inside the database. Up.
I think you only dropped 2 tables.
I think I dropped all. There's a third one right up here. It's just not connected. All right, so insert 01, 01, 01. So it doesn't look like anything blew up. We can double check by going inside of schools, doing, I don't know, select star from addresses. And there you go. I've created a database called addresses. So I created a table called addresses. I've inserted a bunch of addresses into it, and you can kind of see all of the data that I put inside of my database here. Now, if I just want to select everything from Illinois, I only care about Illinois people. How do I do that? Maybe it's a select star from addresses.
Where state equals
Yep. So now I've just queried my database for the people from Illinois. Okay. Or if I wanted one where it's not Illinois, how do I do not Illinois?
bang.
Yeah,
that's awesome.
We need to be more programmatic. Great.
Like that?
Yeah.
Yes.
Oh, wow.
Yes.
So bang equals will give you the not equal to Illinois, so that's everybody else. All right, so we're going to do a little bit more complicated things with, with students and parents and stuff like that. So let's create two legal guardians. Into I think it's just called guardians. Guardians have name, phone number, email, and address. Name, phone number, email, address, and address ID. All right, so let's have John Young. My phone number is 312-111-2222 because this is going on YouTube. Email address is john@codeplatoon.org. And I'm going to be associated with this this first address, this second address number here, right here.
You have to put that number in?
I do, because I said that I expect to put. So I'm giving values for certain columns: the name, phone number, email, and address. So name, phone number, email, and address ID. Because I already know the ID number, I'm just going to throw it inside of here. So I'm just going to hard code that for now.
Oh, because the serial thing, I'm kind of curious about it. Because once you delete, that no longer would be true, right? You deleted at 2.
You didn't exist.
Yeah, but 2 didn't exist anymore yet.
Yeah.
Yeah.
But the serial would probably cascade 3 to be 2.
Yep,
You know.
and then delete that. So let's say we're going to have Josh as well. Phone number 312-555-6677. Address is josh@ And then finally, we're going to associate him with number 1. Okay, so we've got 2 guardians. Let's see if this one works. I'm just going to copy this and throw this in. Okay, so now I can do select star from guardians. I've got 2 people inside that database. Now I want to select from here. I've created 2 guardians. I want to go from the guardian to the address. This is where the joins come in. So someone tell me what to type in order to join myself to address and get to the address. So I want to see where John Young lives.
So, okay, yeah.
Yes.
I'm
I'm just going to type it over here.
Select
Yep.
Star.
Yep.
From Guardian. Oh no. Yeah.
Okay.
And then you can do the join first. You do the join first. So join. We are getting the addresses, right?
Yep.
Join. I'm gonna say address. Address. Okay, I'm confused. Select star from Guardian.
I don't know. I mean, I don't really know off the top of my head. Okay, let's just look it up. Join Postgres.
I have an idea.
Yeah, it's on.
Yeah,
I couldn't remember. It was something where.
you should do it at the beginning. You can join. Yeah, you join addresses, addresses, and join for any other.
Cross join. I'm just gonna do join. Okay. There's join, the inner join. There's full join. There's left join. The right join. There's ready joins. I'm just joining everything. So I'm looking for select from table 1 some sort of join table 2 on table 1 dot common field equals table 2 dot common field. Okay, so it's basically saying I'm going to join one table with another one by using table 1's this field and table 2's this field. In our case, since we have address has an ID number, and guardians has an address ID number, those 2 numbers are the ones that are the same. So I think the SQL statement to select that is select star from guardians, join addresses on, I think it's address.id equals guardian dot address ID, where guardian dot name equals John Young. So what I'm doing here is I am saying I want John's address. So select everything from guardians, join addresses. This is how I'm joining it. And I only want John Young's address. I don't know if this will work. I'm pretty sure it does not. Let's find out. Oh yeah, you're right. Please work. Nope. I think it's addresses. Guardians.
You need guardian.
Nope. Column John Young does not exist. Also doesn't work.
I think it has to be.
Should we go back to the Google?
Yeah, I think it has to be like guardians.name.
All right. Select join where example.
Oh, sorry, it's the double quotes, John.
The double
It
quotes.
expects single.
Oh
Yeah, the double quotes is for the column name.
Let's see it. Oh, it's gross. I'm going to do command \x for extended display. And there it is. So let's take a look at what we typed. Select everything from guardians, join addresses. So I have everything. I've got both the guardian and the address. I just want the address. Oh my God. There we go.
Control L, I think. Or was it Command L? No,
Control L.
it was Control. Yeah, it's Control on the Mac. Or not.
That's all right. All right, so let's just go back to the select star.
Just one. Yeah, yes.
So when you do this query, it create a new table, or does it make a new?
Repeat your question one more time.
Does it create a whole new table now called whatever? I don't know what it's
No,
called.
so it's the select. The select basically just says go inside the database, retrieve the data, and that's it. I'm not creating a view of any sort. Views are a more advanced topic. So it's like for some people, so a view, a SQL view, is basically a series of select statements that are joined together to basically run and look like a database, even though it's look like a database table, even though it's not a database table. It's like a temporary table that you can view certain information that you want to view, rather than running things over and over again.
And if so, where you have select, you can say create table, or create table. Sorry, you can say create table. Start from like the rest, and then you would have a new table that's just.
Technically speaking, yes.
Probably.
Yeah. So we've got the select statement. So we have everything. We have both the guardian and the address over here. So we have, I mean, it's two fully separate records. I'm not sure if I want that. So how do I just get the address? Right now I've got the address and the guardian.
But address instead of star.
I tried address before, it didn't work. Does address.star work?
Yeah.
Yep. So if I want just the address itself, you do the table name dot star. So select everything from the addresses table from here. But the way that join select statements work, just so that we're clear, it's the same select thing, but you're going to join two tables together. So you have table 1, join table 2 on table, like basically you're saying address has something called ID on there. That's going to be equal to the guardian's, which has an address ID. These two numbers are going to be the same. And then if I want to continue on, I just say where the guardian's name is going to equal Janya. Sure. So the way that we use join statements is you have the same select star, but this section is basically saying which tables are you joining together. I'm joining guardians and addresses together. So this is the same. This is which tables you're selecting from, which is guardians join addresses. And now you have to tell the computer how you're going to join them together. You're going to say that the addresses ID is the same thing as the guardian's address ID, because the address ID has number 2, and the guardian has an address ID of 2 as well. That's what I've done over here. And then specifically, I just want the one where the guardian's name is going to equal Janya.
So that's so the join. That's one single entity now.
This is one single entity now.
When if you take away the where, with the UN, it'll print out John and Joshua.
Yeah, I believe it'll print out everything. So this is select, but you're not limiting what you're getting back. So let's see what we get and clear out the
All
screen.
the combinations.
I think it's every combination. Yeah, so there's record 1, record 2, and that's all we have right now because we only have 2 people in the database. But instead of that, I want to just do where guardians that name is equal to Josh Toledo. Or maybe like Josh, and then percent sign. So this is another example. So where the guardian's name is case insensitive like Josh with anything that follows. All right, lastly, let's, do we want to do one more with some kids, associate them? And then we can do an ultimate join to get from the kids to the address, and then we'll call it lunch. Let's throw in 3 kids. All right, so the kid is name, grade, date of birth, and guardian ID. Students, name, date of birth. Actually, it's grade, date of birth, and guardian ID. All right, let's say that I've got 3 kids. Jane is in 1st grade. Date of birth is, oh no, I don't know how to do this one. 2019. I don't know if that's
an 8 on there, so that should work.
like that. Oh, okay.
No.
It's
I think it's just a string.
maybe we'll find out. I'm just going to put it as a string for right now and hope that it works. And guardian ID. Let's see if this one works. Cool. I guess that works. So select star from students. I have 1 student in there, Jane, 1st grade, and I have to alter this person real quick. Jane doesn't have a last name. How do I update? I don't know. Postgres update statement. It's too difficult. I don't want to read this. Let's find one with an example. Oh, tutorials point, Swift notes. All right. Update company set salary equal to, okay, so it looks like update table name set column 1 equal to, okay, where condition. Okay, so I'm just going to grab this and dump it into here. So I'm going to update students set name equal to Jane Young, where yeah, name equals Jane. Actually works, I think. Let's paste it in here and run it. And why is nothing working? Need a semicolon. All right, so let's take a look again. Let's select all from students, and now it's Jane Young. So I've updated this. So the update statement works like this. You write update, the name of the table. You're going to set the column equal to some value where name is equal to Jane. Now, when you do updates, the where is very important because otherwise every single person is going to be named Jane Young in your database. So I've got Jane. I'm going to have a whole bunch of kids. Why not? Jack Young. Jack is in 3rd grade, 2 years older.
You have the same
The same ID because it belongs to me. All right, so let's see. I'm going to go over here, select star from Guardians. All right, so I've got 2 people, and now I want to just select all the kids that belong to me. So I'm going to do select star from students where guardian ID is equal to 1. Now I've got 2 kids, Jane Young and Jack Young, but obviously this is not going to work most of the time because I don't know that, you don't always know that the guardian is going to be number 1. So how do I write a SQL statement that says select all the students, select all this, just the names of the students, where the guardian's name is equal to John Young. So let's write that one out. Write a SQL statement that returns the name of John Young's kids. Thoughts?
Select star from student.
Yeah, it's going to be some variation of this one down here.
Yeah.
So select star from students. Remember, I want the name of my kids.
Are you doing a join or do you just say where?
No, so right now I'm selecting everything. I just want my kids' names. I don't want to know their grade or their date of birth. I just want their names. Select student start names from students, join, I think it's going to be guardians, where is equal to, how do we feel about this? Select the names of the students from the students table, joining onto the guardians, where the guardian has an ID name, has an ID number that's equal to the student's guardian ID, where the guardian's name is equal to John Young. It's a lot, but let's see if it works. So if this works, I should get Jane and Jack. Please work. We just did that.
Need the last square statement there?
Yes. Because I'm saying I want to write a SQL statement that returns the name of John Young's kids. Otherwise, well, there's only two students in the database right now. They're both associated with me. But if I were to create a third one that's not associated with me, I get that person as well.
Can you put the where statement?
Well, actually, your idea
Because I was
was
thinking you don't need to do the
You
join.
get every set where the ID is, right?
Yeah.
So
Right now, there's only two students. Those two students are associated with me. So if I were to create a third student, that's, I don't know,
what's your idea?
Jack Aledo, and I go over here. So now let's do select star from students. We see that there are three of them. There is Jane, Jack, and Jack Aledo. And if I run this same SQL statement without the where, I get all three of them back. So that's every single student. It's equal to another guardian. But if I just do this one, yep. But if I do it this way, I have Jane and Jack.
I was thinking, do you need the join part? Like, could you just say where guardian is that mean? That's down.
Maybe. The short answer is yes. Short answer is yes, you do need the joins. Okay. One last thing. This will be the last thing, and then we'll take lunch. I want to get the student's address. Write a SQL statement that returns the address of Jane Young.
Wouldn't there just be a join statement the other way, and then where students.addresses?
It's probably something similar to that, but keep in mind, when we first created this, we have to go from students to guardians to addresses.
Like select address
Students.address.
Select addresses dot star.
addresses.
Yep.
Join guardian. Join students.
Yeah. You got it.
You
On.
have to- you have to go
On
from
guardian.
On
Guardian ID.
It's gonna be some variation of this.
it's going to be guardian's idea. So which one goes to which?
So the guardian has something called an address ID. The address has something called ID. And it's this other one as well.
Yeah.
So it's two statements. Where students.name equal Jane Young. I think this works. Let's find out. Please work. No. Oh, it's because I have an extra space.
Is the on
address.
You need an on after the first join and then an on after the second.
Addresses then?
You don't need a space between that. Oh.
Do you replace and with on?
Oh, address.
Okay, we're getting a little bit closer. Students.name, guardians.id, students,
Oh,
guardians,
guardian.
address. I don't know. Let's take a look. Multiple joins, example, Postgres. Oh, it looks like it has to be join on, join on.
Yeah.
Okay, cool. So we had it a little bit wrong. Join,
This is a place to end it on.
here we go. So a lot of Googling. I don't know all the answers to every single SQL question either. So I Google everything, I just try it until it works. But this one works because basically what we're doing is we're joining the addresses to guardians, and this is how we're joining them together. And we're going to join that whole thing to students through this statement right over here, and then we're going to do where the student's name is equal to J.